So using Pythagoras' theorem, c squared equals a squared plus b squared, or the other way around, then we can surmise, and this is where it gets a little hairy, that c is equal to the square root of a squared plus b squared. It's a crazy idea. It's something that can really easily be mistaken. The square root of a squared number equals that number itself. Because if I had 5 squared, what does 5 squared equal to, everyone?
25.
And what is the square root of 25? Yeah. So sometimes the final answer may not be the result, may not result in a whole number. If you plugged into your calculator square root of 3, you're not going to get an integer. You're not even going to get a terminating decimal. Same thing with square root of 24. There's no two same whole numbers that will go into that will make a whole number. And sometimes, this is a new term for us, we get what's called a surd. Surds are shown with this square root sign, and that's their simplest form. That's what we're going to call the exact number, the exact answer. So they're not whole numbers. They cannot be written as fractions, and because of that, they're known as irrational numbers. And we've seen these before. So they would, written as a decimal, continue forever and ever with no repeats, no pattern, just like our friend pi. So the word is surd. Surd is the word. An example of a surd, or an irrational number, is square root of 2. Yes, you can plug square root of 2 into your calculator, but it will give you the beginning set of numbers. So if you wrote those numbers down, it's going to be some kind of approximation. It's a guess. Whereas square root of 2 is exactly the right number. Just like pi is exactly the number, and your calculator knows it. Just a note here, the square root of a squared plus b squared is not a plus b. And again, this is so important. It's because there's that plus in there. If it was a squared times b squared, we could be talking about a different story. And for example, if we did it, 3 squared plus 4 squared does not equal 3 plus 4. Because 3 squared is 9, 9 plus 4 squared is 16, is 25. What's the square root of 25? 5 again, so it doesn't work. But if c squared is k, whatever that number is, the square root of k is c. So let me show you. So we're finding the length of the hypotenuse. The hypotenuse is always the longest side. We read all the instructions, find the length of the hypotenuse, which is c, for these right-angled triangles, that matters, and then we're going to round the answer for b to 2 decimal places. Okay, so the formula is c squared equals a squared plus b squared. We're looking for what c squared is. I'm going to choose either 6 or 8, doesn't matter. 6 squared plus 8 squared. So c squared is equal to 6 times 6 is 36, plus 8 times 8 is 64. C squared is equal to 100. So c is equal, therefore, here's my therefore, c is equal to the square root of 100, which you can probably tell me is 10. For this one, we're told that we're going to have to round it. So again, c squared equals a squared plus b squared. I always start out with my formula. C squared is, let's say, 7 squared plus 9 squared. It could be 9 squared plus 7 squared. Doesn't matter. And so 7 squared is 49. 9 squared, 9 plus 9 is 81. So if I'm lucky, those add up to 130. And that's c squared. So if I plugged it into my calculator, therefore, c is equal to the square root of 130. And I will find, I don't have my calculator in front of me, but if I did, I would find that this would be equal to 11.4 something, 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 something. But I've been told to round it to 2 decimal places. So I'm going to write the 0 in there. Even though the 0 doesn't really change the answer, 11.4 is the same as 11.40, I have been told to round to 2 decimal places. Therefore, I will obey and round to 2 decimal places. Now, you might sometimes find, lo and behold, a practical application for this. So a rectangular wall, that's important because it tells us that we have 90-degree angles, will be strengthened by a diagonal brace. The wall is 6 meters wide, so that's one of our numbers, and 3 meters high, so that's another of our numbers. Find the length of the brace to the nearest centimeter. So if I'm looking for my brace, I'm going to put in c squared, because that's going to be the brace, equals a squared plus b squared. And I hope you can see this brace is equal to the hypotenuse, because it's opposite of that right triangle, and will also end up being the longest, equals, let's say, 3 squared. I don't know why I like putting the shorter one first. 3 squared, so that is 9 plus 36, so c squared is equal to 45. Therefore, c itself is the square root of c squared, and the square root of 45 gives us 6.71 meters. And our calculator will have some more numbers flying around, but remember we're asked to find this to the nearest centimeter, so we're going to multiply that by 100. Therefore, we have 671 centimeters.